Hello, my name is Emeka and welcome to my YouTube channel. And in this video, I'm going to be demonstrating how I developed a DBT data pipeline. And I'm going to basically divide it into 4 parts. The first part is going to be how I created the raw data and stored it in S3 buckets. And then the second part is going to be about how I staged this raw data in Snowflake. And then the third part is going to be how I apply a data transformation using DBT on the stage data in the Snowflake. And then the final part will be about how I automated the workflow using GitHub Action. So stay with me as we continue with this demo. Professionally, as a data engineer, I have access to a lot of raw data from the IoT sector anyway, but I can't use that for a personal project. So I had to be able to find a way to get the raw data. So I simulated this particular raw data using this Python code and using Faker to actually get something that is a bit realistic. And this is the code with which I created the raw data. So as you can see, these are just some of the features that are contained in this raw data. We have the transaction types, basically giving the kind of unique values you are going to have in them. We have like purchase, refund, transfer, interaction type, payment method. We have a PayPal, bank transfer. These are just the 3 unique kind of payment method we are using in this particular data. And for the merchants, we have the Amazon, Walmart, Target, eBay, and Best Buy. These are the unique values we have in them. And then we also defined the user metadata here. So you can see the user ID, the age, gender, account creation date, location, or whatnot. And then going further, you can see where I basically have to, here, hold on, here you can see where I saved the data in my S3 buckets. So this is the bucket name, fraud detection raw data. And inside this fraud detection raw data buckets, we have this folder called raw data. So inside this folder, we have the data partitioned by year. Like we'll have 2022, 2023, and then 2024 data. So they are partitioned by year, and inside this partitioned folders, basically we have the JSON files in them. So this is how I created the raw data. So I'm going to show you in S3 how they appear in S3 bucket. So this is my S3 bucket. You can see this is the only bucket I have there. We have fraud detection raw data that we created, and inside it, open it up. You can see the folder, raw data folder, and inside this raw data folder, we have these partitions, year 2022, year 2023, and year 2024. So each of them hold the record for the corresponding year. So this is the first part of this demo, how the raw data is created and stored in S3. So the only thing I'm using this S3 for in this particular project is just to store the raw data, nothing else. So, but in case we have, because this is kind of a batch processing demo, not streaming data. So it's basically so this is the first part of this demo where we have just created the raw data and store the raw data in our S3 buckets. So the next part now is going to be the second part, which is basically staging this raw data in Snowflake. So here in Snowflake, remember this project has already been completed. I'm just showing you how I developed the whole thing. So here in Snowflake, you can see I have 2 databases, a dev database and production database within the same account. Because this is just for demonstration purpose, so I only created 1 account for this. Maybe ideally, in some cases, you might have development account and production account all separated. But here, I'm just having everything in one place. So this is how I created a database, basically using this SQL command, create or replace database, give the database name, which is dev Emeka fraud detection, which is this now. And then we created for the production database as well, prod Emeka fraud detection 2, which is this. So these 2 SQL commands created the database for us within this particular account. So now the next thing is to stage our raw data here in Snowflake. So it can either be in dev or prod or in both of them. So in this case, I'm staging in both of them. So that's why I created for dev here, create or replace stage in my S3 stage dev, and then also created for prod here as well. Here you give your AWS credentials, basically give access to the S3 bucket from Snowflake. So which is what I did. You also give the region, in my case it's EU Central one, which is Frankfurt, and then the JSON, the file format in my case, which is JSON. So I did this for the development database and also did it for the production database. And the next thing is to create the staging table in both databases. Here I created for development, I created this. So create or replace tables transaction staging. So this table is where we stage the raw data. Ordinarily, this I can also perform using DBT to maybe a more structured format. So whatever I did for development, I also did for production. But the thing is, for development, I'm not going to use the full data because this is where we'll actually do the development of our project. So I'm not supposed to have access to the whole data, which basically will help us cut costs. So here I can see where I loaded the data into these tables. Here for development, copy into transaction staging. So from this is the raw data, we are copying from this raw data into this transaction staging. So file format is JSON. See what I did, pattern is equals to the year is equal to 24, and inside the 2024 folder, we are taking every JSON object inside it. So it's just a subset of the whole data that we are taking for development. We are not taking the whole thing because when we are going to be working with DBT, mostly we are going to be working on the development database. So because of that, I don't want to have access to the whole production database. So just using a subset of it, because since the data is of the same structure, whatever we do in development can be applied to the production data. So here we are only taking for year 2024, and every JSON object inside year 2024 is what you are using for development. Now, unlike production, you can see in production, we are taking for every year and every JSON object inside this staging, inside the my S3 staging prod, and we are copying it into the transaction staging table. So this is the table we are going to be referencing in. So this is the end of the second stage, second part of this demonstration, which is basically how to stage the raw data in Snowflake. So the next part now will be the actual transformation itself using DBT. So before we jump into the practical application of DBT, we need to understand what DBT is. DBT stands for Data Build Tool. So what are we using it for in this case? DBT is used to maybe clean a raw data, transform the raw data, and then organize the raw data into usable tables. If relationships are existing within these tables, DBT also helps us build a relationship between these tables. So in our case, we have a JSON raw data, and then we need to transform this JSON data into structured fact and dimension tables. Fact table simply have the whole record, while the dimension tables simply have the dimensions of, let's say, the users and also the devices being used. So this is what you're trying to do using DBT in this case. And personally, how to use Databricks medallion architecture structure to organize these tables into different layers. We have the bronze layer, the silver layer, and the gold layer. So the bronze layer being the raw data. So once you see the bronze, be like B arrow prefix, you know that it's bronze, and you know that it's the raw data. And in most cases, you don't have anything to do with the raw data, except maybe the engineers. And then we have the silver data, which is now the transformed data, the fact and dimension tables, and then which is structured. So when you see SI prefix, which stands for silver, you know that these tables are the transform tables, which the analysts and maybe other users within the organization can actually have access to, at least with the right access. And then we have the gold table, which is usually the aggregated tables for the business insights or for our dashboards and all that. So once you see GO prefix, it simply means a gold table. So now let's jump into the practical application of DBT in our project. So first of all, we have to create a virtual environment, basically to isolate our dependencies and prevent conflict with system-wide packages. We all know, I believe, how to create a virtual environment. For me, I'm using Windows, so I just type a Python mvenv dbt environment. So you can see this is already created. Here we have our virtual environment, which is this. I've already created this before. This is a completed project. I'm just demonstrating how I did it. So next is to activate our virtual environment. And then after that, we need to install the DBT adapter for Snowflake because we are using Snowflake adapter. So we have to enable interaction with Snowflake databases that we have already created. So in order to do that, we need to install the DBT Snowflake adapter. So we can do this by just typing pip dbt. So hit enter and then we install. I'm not doing that again because I had already done that before. Then once we are done installing the adapter, we can check the version of our DBT. If it installs successfully, we will see a version after we type this command dbt version. Enter. So as you can see, we have the core installed 1.8.8 and it's up to date, and the plugins, which is Snowflake, is 1.8.4 and it's also up to date. So that means our DBT adapter, our Snowflake adapter installed successfully. Now we need to initialize our projects, our new DBT project directly. Here we have the project directory, my fraud detection project. I had already done this before, that's why you're seeing it here. But in the course of initializing, I ran this command dbt init my fraud detection project. So once I run this command, it gave me this, and this contains the package from dbt that we need. It contains our model, sample model, and it contains the macros, the model, seed, snapshot, and then the tests. If you go into model, you see the sample model, but in my case, I've already removed them because I don't need the sample one. I need my actual model, so which I built here. So once you initialize, dbt will give you all this, and then you use it to build your transformation logics, and whatever you need is also included in this folder. Now, in the course of initializing, you'll be prompted to enter some of your credentials, which are going to use to establish that connection between dbt and your databases in Snowflake. Like you are going to be requested to enter your account and your database, your password, your role, the schema you are targeting, and then the type, which in our case is Snowflake. So you're going to enter these credentials, and if everything goes well, you are going to see it. Basically, when you try to test by running dbt debug. But in my case, that's what I did. And then I entered all that is required and everything went well. And you can view those credentials in your profiles.yaml file, which I'm bringing up. Here you can see, this is the profile.yaml file. This is the project we just initialized, this my fraud detection project. And then I defined both for the dev and for the prod in this case. So the configurations are here. Because I'm using one account, you can see account here. Account here is the same as the account in prod because I'm basically using one account, but the databases are different. So you can see dev and then you can see prod. This is what we created earlier. And then the password, which I've already hidden in my environment, you have to also include that here. And then the role name in my case is account admin. That is my Snowflake role name is account admin. And the schema I'm targeting is public. And then the type is Snowflake. And then user, I also hid this as well. And then the warehouse here is the cluster which you are going to use to run whatever you're going to run within the DBT environment, but it's coming from Snowflake. So it's your compute resource from Snowflake. That is your warehouse. So in my case, I'm using my DBT warehouse. So these are the configurations and they are contained in your profile.yaml file. basically all these are configured after you run dbt init my fraud detection project. Once you run that, you get all this because you have entered this. That is what this is going to bring out for you. So we can test our connection after initializing. We can test our connection to see if it's successful or not. If there's still anything that is pending, then you're going to get an error. But if everything goes well, then you're going to get a success. So how do we test our connection? By running a dbt. So now that we have tested the connection and everything passed, let's go into developing the model itself. The model here being the SQL transformation logic that would transform the raw data into fact and dimension tables, and then also into aggregated tables. Remember, we said we are going to be using a Databricks Medallion architecture structure to structure my table. Here we have, if you go into model is where we have the SQL logic that transform this raw data into what we want. So going to model, here you can see where I organized the table into this structure, the bronze, gold, and silver. The bronze being the table that contains the raw data, and then the gold being the tables that contain the aggregated data, and then the silver being the table that takes the source from bronze that contain the structured data, which in my case I'm dividing into fact and dimension tables. So let's look at the bronze table. This is the bronze table. The name you are seeing here, BRO fraud detection raw data historical, is basically the name of the table in Snowflake at the end of the day. So this is going to be the name of the table. And this is the logic behind the transformation. So here we are saying materialize equal incremental unique key transaction ID. Here, what you are saying here is that you don't need to refresh the whole table each time this logic runs to actually get what is new and append into what is already existing. What it does is basically it checks the transaction ID that is not already existing within the table and then fetches them and then append it to what we already have. So here we define the table, the columns and their data types. And then here we are saying from source fraud detection transaction staging. This is where it's taking its source from. So, but we define this source somewhere else in this model. So if you go down, you see source here, sources, and then click on it. The name of this source is fraud detection, and database we are targeting, we are making this dynamic because at the end of the day, we are going to be automating this workflow using GitHub Actions. So it's going to detect automatically which database we are targeting. So that's why we are making it dynamic here. So we are saying target.database and the schema is public. Now the name is transaction staging. This name is what we created in Snowflake. Remember, this transaction staging table is what we created in Snowflake. This is the table we are targeting now to take its source from. Here, now we'll go back. You can see the name of the source, which is fraud detection, and the table name is this. And we are saying if incremental, where transaction ID is greater than maximum transaction ID. That is what we are targeting in this case. So if the transaction ID that we have is greater than what is already existing, the maximum of what is already existing, fetch it and then append it to what we have already. So it's not going to refresh the whole database each time it runs. It only gets what is new and I'll append it to what is already existing. That is what the bronze does. Now we go to silver. The silver here, like I said before, is the fact and dimension tables. The fact table containing the full record and the dimension table containing the unique attributes to the devices and then the users. So let's take a look at the transaction fact. Now, look at, it's still the same thing as incremental. It's not going to refresh the whole table each time it runs. You just take what is new and then append it to what is already existing. So still the same kind of process. And then here we are taking its source from, it's referencing the bronze table. Don't worry, later we are going to see the lineage graph to see how this data is flowing from the upstream to the downstream, the tables that are taking their data from which tables, we are going to see everything. So here we are saying it's taking its source from the bronze table. The same thing applies here as well. And then we are creating We are creating a temp table here, transaction fact. At the end of the day, we are selecting these columns from the transaction fact, and then this is what creates the transaction facts table in Snowflake. So if you go to Snowflake, you're going to see SI transaction fact table. Then we'll have for the user, this is the dimension. The devices is also dimension. And then we use some window functions here. Then we come to the gold, which is aggregated. Here we are not using anything incremental because the value you are getting from this table is just one record. So we don't need to say it has to be incremental, so just table. Now here we have the Go merchant risk assessment. Remember, these are aggregated, so that's why you're seeing count, sum, average, count. They are the aggregated table. These are the business logic tables. So this is what we use for our dashboards at the end of the day. That doesn't mean that we can't use the silver tables for our dashboard. It depends on what you are trying to achieve. But in most cases, we use the gold tables for our dashboards because they are already aggregated. So the same thing was done for all these other gold tables. So here you can see the structure once again. We have the bronze for raw, gold for aggregated tables, and then silver for the transformed structured tables, dimension and fact. And then here we have developed our models. So how do we know if they are working fine? How do we know if everything we wrote here is fine? And how do we know that the tables will be created? And how do you know that they will be populated? So we have to test our model. So how do we do that? We simply type dbt run. Ordinarily, we would have given the target, the database we are targeting, but by default, let's go back to our profile.yaml file. Let me just show something. So look at our profile.yaml file. By default, you can see target the lowest part. We set target development. So default environment is development. So whenever I say dbt run, it's going to run on the development database. So the application will be on the development database, not on the production, because by default it's development and we are in development phase. So come back here, we say dbt run simply because we are working on the development phase. So click run. If everything goes smoothly, we are going to see it. It's running now. So we can see we have 9 models. You can see 9 of 9 okay created. Now you can see completed successfully. Now look at the summary done. We have pass equal to 9, 9 out of 9 models, warning 0, error 0, skipped 0, total equal to 9. So everything ran successfully and everything was okay. Everything was fine. So now let's see in Snowflake if these tables are now existing. Let's go back to Snowflake. So we are now in Snowflake and let's refresh. This is development database we are talking about. So let's collapse it. Go to public, go to tables. So the tables are here. The bronze table, the aggregated tables, which are the gold tables, then the silver tables, everything is here. So we can just view one of them to see what we have in it. Let's go to development database, public. Let's just view the fact table. Let me take this off, place in editor, and run. So it's running. So you can see the transformed table. You can see 2024 data. Remember, we are only using, and the subset we are using is just 2024 data. So that is what you are seeing here now, though we can check that later. And everything looks fine. We have is fraud 0, 1 Boolean values, which we also defined. So is fraud 0 means no, 1 means yes. Now, suspicious flag, 1 means yeah, this transaction is suspicious. 0 means no, it's not suspicious. Then we have the anomaly score, 0.7 towards 1 means anomaly, then towards 0 means okay. So as you can see, our tables are created and then they are a subset of the full data. And for now, the production tables ordinarily have not been created. Those will only be created when we deploy it to production. So now let's go back to our VS Code. Now our tables have been created, but At the end of the day, it's ideal to have some kind of unit test or integration test to be sure that everything is okay before deploying this into production. So now we are going to check for the unit test. So as you can see, each layer here, the bronze, gold, silver, for each layer, there is a test attached to it, and the test is contained in this schema.yaml file. This is where we define the test. So for bronze, this is the test for bronze. For gold tables, this is the test for gold, this one here. And then for silver, we also have the test for silver. So let's see what is contained in this. Here we have some basic tests. So here is what we have. We are saying that what table are you targeting? We are targeting bronze table. That is the table we are trying to test now. We give a short description for that. Then what columns are we testing? Here we have transaction ID. So what are we saying about the transaction ID? What do we need? We are saying that it must be unique and it must not be null. So if it's not unique, then there's going to be an error. And if we have null values for transaction ID, there is going to be an error. So what next? We are testing the user ID column. What are we testing? It must not be null. Transaction amount, it's just some basic tests. Then come down here is fraud. What are we having in fraud? We have two unique values, 0 and 1. This value, we are not expected to have any other values apart from this 0 and 1 in this is fraud column. So these are the accepted values, 0 and 1. So if peradventure tomorrow we have something like 3 or 4 appearing in this particular column, this test is going to fail. And if the test fails, that means the deployment to production will not happen. So for suspicious flag, we also have these accepted values as 0 and 1. So these are the basic tests we are running for the bronze table. Then the gold tables, we have this. So the models, these are models. We have the name of the model, which is not the name of the table. Then what test you are performing, the column name we are targeting, the kind of test. So another model here, go user behavior metrics, the column names you are targeting here, another model here. That is how we define multiple models test in just one script. So, and then for silver, we have this as well. The same way we define for gold. We have the models and the name of the model, and then the columns we are testing. Same thing that we did before. Like in this case, we said account name, account status. The test is not null, and the accepted values are active, suspended, or closed. So if any other value appears in this particular column that is not any of these three, then the test will have to fail. We also have for this as well. So after writing all the logic of the test, how do we now test to see if our tests are passing or not? So we'll simply use the command dbt enter. Then we'll see the number of tests we're performing, and then each test, the one that passes you see, the ones that fails you see. So you can see we have 38 tests. So 1 of 38, 2 of 38, and so forth. So you can see pass, pass, pass. The tests are passing. If anyone is not meeting this criteria, then it's going to fail. So finish running 38 data tests in 0 hours, 0 minutes, and 33 seconds. It's completed successfully. Now this is the summary. Done. Pass equals to 38, warning 0, error 0, skip 0, total 38. So everything looks fine. Now let's view our data flow lineage graph to see how our data flowing from the upstream to the downstream tables. And to do this, we have to first of all type dbt docs generate. This will basically create documentation for our dbt project based on our models and sources. So we'll type dbt docs generate, dbt docs generate. And after this, we are going to type a dbt docs serve. This serves a generated document locally in our web browser so we can see the lineage graph itself. So let's wait for this to finish running and then we serve. So the docs generator has finished running. So now we type dbt doc serve. So doc serving. So now we can view the lineage graph on our browser. Let's open up our browser and view the lineage graph. We show us the lineage graph. This particular point. View lineage graph, click on it, and then you can see the flow of data, the way it's flowing from the upstream tables to the downstream tables, and the relationships they have. Here you can see fraud detection, transaction staging. So this is the one we have in Snowflake. This is the one that is serving the other tables, the bronze table. So from the transaction staging, the bronze table is getting its data. Then the bronze table now is serving the fact and dimension tables, which are the silver data, SI device dimension, SI user dimension, SI transactions fact. And then from SI transaction facts, which contains the full data, basically, we are getting the aggregated gold table data, which is Go real-time fraud detection, Go fraud detection dashboard, Go merchant risk assessment, and Go user behavior metrics. So here we also have another gold table, which is taking its source from 3 different tables. You can move it around to see it properly. So this gold table is taking its source from the transaction fact silver table. It's also taking its source from the Go merchant risk assessment and then also from Go user behavior metrics. So this is the lineage graph. From here, we can see clearly how the data is flowing from the upstream table to the downstream tables. So now that everything is looking good, the tests are all passed, the models are working fine, we have to define our workflow using a GitHub action, which is the final part of this project. So let's go to that part. So this is where we define our workflow. Sorry. So this is where we define our workflow for our project using GitHub Action. As we know, for you to start a workflow, you have to create this .github/workflow folder, and inside it we are having our dbt.yaml file, which contains the workflow itself. So as you can see here, we are saying that on pull request, and if the pull request is targeting the masters, then you have to run the test. So it's only when you run the test and then all the tests pass, then you can say, okay, you have the option to merge the changes. So that's what we are saying, what we are doing here, because we don't really want to disturb what we have in production already. The master in this case is basically for the production, while the dev branch is for the development. So if you are making a pull request that targets the master, then you have to run the test. It's part of the check that has to be done before you can merge the pull request, you can merge the changes. So and we are saying that on push to the dev branch, you have to run the test. And on push to master, then you have to deploy to production. So in this case, we have two jobs. We have two jobs. One is test and the other is deployment, which is this. So for the test, these are the procedures that you must undergo for us to actually run the test. So here we are talking about installing the virtual environment and then activating the virtual environment and then installing the DBT Snowflake adapter again. But everything we did locally, we have to also do within GitHub. So, and then we'll now set up the Snowflake credential. In this case, I'm hiding the credentials in GitHub environment. And then the profile.yaml file that we define locally, we also have to do that here within this workflow. So here we define for dev and for production. Before we run the test, we have to do all this. So the account, everything is also hidden within the GitHub environment. And then this is where we run the test. We say dbt test. You can see here we are targeting the dev. So dbt test dev. And then this will run. And if everything looks fine and we are merging the changes to master, then we can deploy. So you can see here, it needs the test to be successful. It's only when the test is successful, that is when we are deploying. So we'll do the same thing all over again. The credentials, everything given again. And at the end of the day, we say dbt run. And target now will be for production. So remember, in production, we define the YAML file. And in the YAML, we are saying that the database is production database. So this is where it will take its source from. And this is where the tables will be created once you run the dbt run in production. So we are going to see this in practice. Let's make some changes. I think I've done some changes before. So let's just add all the changes we've made. Penny, git add all. Let's commit the changes. Git commit. Let's give this message. So we are pushed to dev now. So let's go to GitHub and see the workflow. So as you can see, we are now in GitHub. You can see dev had recent pushes 2 seconds ago. This is just the push we just made. So let's compare. Let's compare and pull. I just create a pull request. Ordinarily, at this point, maybe you can configure it to assign to a different developer, a different colleague to review the changes before merging the changes to masters. But I'm not doing that because this is a private project and I'm not assigning to anyone. So let me just create a pull request. Now you can see we created a pull request. So for the whole check mark to give us the go ahead that everything is fine, the test has to run. So that is what it's doing now. Let's view the details. So the test is running again. So you can see the test passing, just like we did locally. So this one completes. You can see that the deployment is skipped because we haven't made the changes. So it will run the deployment. So let's go back. So you can see all checks have passed, including the test. So now we have the option to merge our pull request. Let's go to actions and see. So you can see now that we have merged, it's running the test again. And if all the tests pass, then it will start deploying. That is how we defined our workflow. So let's just see. So you can see the test is complete. And then, so test complete, now it's deploying. So let's see what is happening in deployment. So you can see run dbt model for production. So this is where dbt run target production is now happening. So completed successfully. So as you can see from test to deployment, and deployment is done as well. So this is how we define the whole workflow. Upon pull request, before you merge the changes to master, you have to run the test, and the test passed, and then you have to start deploying the changes. And then basically now the tables in the production database in Snowflake must have been populated with the whole data. So let's go and take a look at that. So this is for dev. Let's refresh. Go to prod. This is production database. Go to public because we are targeting the same kind of schema. And then go to tables. So you can see we have the tables, the replica tables in production. But in this case, we have the whole data here, not a subset of the data because this is the production database. Here we can, let's just view the same thing we did during the development. Let's go to production. We are trying to view the fact table, this, and then enter. So here you can see we have 2022 data. So I have 2022, 23, and 24 data here. So this brings us to an end to the data pipeline project. What you have seen so far, we have seen how we simulated the raw data, and then how we staged the raw data in Snowflake, and also how we did the transformation using dbt, and then how we defined the workflow using GitHub Action. So I hope and I believe that this demonstration has been interesting to you, and thank you so much for watching, and have a nice day.